Okay, as promised, all will be revealed. The program that we've written thus far has been very successful, and it has achieved its intended outcome very well. As stated at the very start, PLC, or Programmable Logic Controller, its main purpose is to make processors autonomous. And it's able to do this because of the fact that it has a computer or digital computer as its brain, its processor, and it's able to process logic that is programmed to effectively control modules that are connected to peripherals that can then perform a process. And in most cases, the home of the PLC is in the industry, in industries that have repetitive processes, mechanical repetitive processes, and they use electrical devices, thus mechatronics in the industry, and PLC being that first step towards that. Now, everything that has been done with this traffic light program has been very easy using a software such as Unity Pro. But what we've done in Unity Pro is use it to create a program that, if you can see, is clearly being transferred to the PLC and stored. So once the program is inside the PLC, and in our case it's a demo box which has the purpose of demonstration, it's not designed to be accessed repeatedly, isn't it? It's stored. It becomes part of the PLC's memory, and it executes that task until it's told to stop, and then perhaps the program is altered, re-uploaded, and run again. So during its running, control of the program is almost not possible without the use of Unity Pro. Therefore, another interface is required. In fact, it's necessary. And that interface is SCADA. SCADA stands for Supervisory Control and Data Acquisition. So more appropriately, that interface is a SCADA interface. There are many programs that can create a SCADA interface, but to simplify it down, a SCADA interface is very much like a web page. It can be accessed on the computer display and manipulated as would any computer software. It can be done so on a different side of the planet using internet. It can be done right next to the PLC, as has been done so far using a PC with a direct Ethernet connection. But the point is, it is an interface that is no longer part of the build and transfer phase. It's past that. It's now an interface that operates in tandem with the run phase. So let's go ahead and take a quick look at what's actually going on here. SCADA, standing for Supervisory Control and Data Acquisition, we want to implement elements of control and data acquisition. In this program we've created a subroutine which is called counter, and this counter is going to count each full sequence of the traffic light. So as the light cycles through red, yellow, green, it's going to count once. On top of that, we've also got a control element, which is these breaker switches, which is going to allow for the counter to reset as indicated, and at the same time it's going to suspend operation of the traffic light. If we look at the operator screen itself, a reset button has been put, and it's becoming very apparent that the operator screen, while initially viewed as a great control platform, it's not exactly for that as much as it is for testing the build and to ensure that the program is functioning as expected. So in vain of that, we shall connect to the PLC, and the program is already running, as you can see, and we will test our control element and have a look at our counter element. So pressing that reset button, which is a latch button, completely pauses and halts all timers and the program itself. And as you can see, the counter value at this point is 0. Now, unlatching the reset button and allowing the suspended program to continue running, every time a full cycle is completed, now the counter goes up. So as part of the build phase, the program is a success, but what we want to do now is to create a SCADA interface that is going to allow us to view the sequence count as well as operate the reset breaker switches.